The Atlantic Wall was not merely a propaganda slogan, it was a jagged scar of concrete and steel that ran from the Arctic Circle to the Spanish border. By 1944, the Third Reich had turned the coast of Europe into the most heavily fortified line of defense in human history. Field Marshal Erwin Rommel, the Desert Fox, had spent months obsessing over the tides and the sand, planting millions of mines and aiming thousands of artillery pieces at the waterline. He knew, as did the Allied High Command, that an invasion force was gathering in England. But Rommel slept soundly on many nights because of a simple, undeniable fact of logistics. To land an army was difficult, but to feed it was impossible without a deep-water port. He believed the Allies would be forced to attack a major harbor like Cherbourg or Le Havre, and he had turned those harbors into impregnable fortresses. For the planners in London, the situation was a mathematical nightmare. A modern mechanized army consumed supplies at a voracious rate: fuel, ammunition, food, and spare parts. Without a continuous stream of cargo, the liberation of Europe would stall on the beaches, leaving the infantry exposed to annihilation. In this war, battles were won not just by bullets, but by logistics. Now let us return to the tension-filled planning rooms of London, where a desperate idea began to take shape. The ghost of the 1942 Dieppe raid haunted every meeting regarding the invasion of France. At Dieppe, the Allies had attempted to seize a port intact to prove it could be done. The result was a catastrophe. Canadian and British troops were slaughtered on the shale beaches, pinned down by crossfire from the fortified headlands. Tanks floundered, landing craft were obliterated, and the operation was called off in a haze of smoke and death. The lesson was written in blood. The Germans would destroy any port before letting it fall into Allied hands, and the cost of taking one by direct assault was too high to pay. This strategic deadlock forced the Allied commanders, including General Dwight D. Eisenhower, into a corner. They looked at the maps of Normandy. The beaches there were wide and sandy, suitable for landing craft, but they were far from any major port. If they landed at Utah, Omaha, Gold, Juneau, or Sword, they could get the men ashore, but they could not sustain them. A division of troops required approximately 600 tons of supplies every single day. The invasion plan called for multiple divisions, swelling to an army of millions within weeks. The math simply did not work. The moment the troops landed, the clock would start ticking. If they could not secure a massive influx of heavy tonnage within days, the German panzers would counterattack and drive the starving, ammunition-depleted Allies back into the sea. The skepticism among the naval and engineering staff was palpable. The English Channel was known for its treachery. It was a volatile body of water with high tides and violent storms. To rely on offloading cargo onto open beaches using small landing craft was a recipe for disaster. Bad weather would halt operations, and the backlog would strangle the offensive. The generals needed the calm waters, the cranes, and the piers of a harbor. If they could not capture one, they faced the terrifying prospect of canceling the invasion entirely. It was Winston Churchill who cut through the paralysis with a concept that bordered on madness. Years earlier, during the First World War, he had toyed with the idea of artificial islands. Now, in a memo that would change the course of history, he demanded a solution. He wrote to the Chief of Combined Operations with a directive regarding piers for use on the beaches. They must float up and down with the tide, he insisted. The anchor problem must be mastered. Let me have the best solution worked out, he concluded, adding that he did not want arguments about the difficulties, only the solution. The order sent a shock-wave through the engineering corps. Churchill was effectively asking them to bring a harbor with them. This was not a request for a pontoon bridge or a simple jetty. The requirements were for a port the size of Dover, capable of handling 12,000 tons of stores and 2,500 vehicles daily, to be transported across 100 miles of open ocean and installed on a hostile coast under enemy fire. It had to survive the unpredictable Atlantic weather and the 20-foot tidal range of the French coast. Top-secret groups of civil engineers, naval architects, and military strategists began to convene in smoke-filled rooms to dismantle the problem. They realized that a harbor required two main components: protection from the rough seas and a way to get cargo from ships to the shore. Nature provided neither at Normandy. The Bay of the Seine was wide and exposed. Any ship anchored there would pitch and roll violently, making the use of cranes impossible. Therefore, they needed breakwaters, massive walls to calm the water. The scale of the proposal grew with every meeting. They would need to create a sheltered anchorage covering 2 square miles of water. This meant building miles of breakwaters. Since they could not build them on-site with concrete mixers and laborers while under German artillery fire, the structures had to be prefabricated in England. They had to be immense, heavy enough to sit on the ocean floor and resist the crushing force of the waves, yet buoyant enough to be towed across the channel. As the scope of the project, codenamed Mulberry, became clear, the engineers realized they were not just building a military asset. They were engaging in one of the largest industrial construction projects of the war. They needed steel, concrete, and labor in quantities that threatened to derail other essential war productions. The skepticism remained high among some of the brass. To many, the idea of towing millions of tons of concrete across the channel seemed like a fantasy, a desperate gamble born of fear. Yet the alternative was the certain failure of the invasion. The die was cast. The Allies would not capture a port. They would bring 2 of them. One for the Americans, Mulberry A, and one for the British and Canadians, Mulberry B. They would be built in pieces, disguised and hidden in the rivers and estuaries of Great Britain. The clock was ticking toward D-Day, and the engineers had to invent entirely new technologies to make concrete float and steel roads flex with the waves. The impossible logistics challenge had been accepted, but the design and construction hurdles that lay ahead were enough to break the resolve of lesser men. The race to build the keys to liberation had begun, and failure was not an option. The solution that emerged from the secretive planning offices of the War Office was a triumph of brute force engineering over the laws of nature. The engineers realized that to calm the violent waters of the English Channel, they could not rely on flimsy barriers. They needed mass. They needed to place an immovable object in the path of an irresistible force. The result was the design of the Phoenix caisson, a structure so massive and geometrically complex that it resembled a brutalist cathedral more than a piece of military equipment. The concept was deceptively simple, yet technically agonizing to perfect. A Phoenix caisson was essentially a hollow concrete box, reinforced with steel, that functioned like a submarine. While empty, the air inside provided enough buoyancy to keep the structure afloat. allowing tugboats to haul it across the water. Once it arrived at the designated position off the Normandy coast, the crew on board would open a series of seacocks, massive valves designed to flood the internal chambers. As the water rushed in, the buoyancy would vanish, and the concrete leviathan would settle onto the seabed, creating an instant solid wall against the waves. To the draftsmen working under dim lights, the scale of these units was staggering. The largest Phoenix caissons, designated Type A, measured 200 feet in length, 60 feet in height, and weighed over 6,000 tons. They were as tall as a 6-story building and as long as a city block. And the invasion plan did not call for just one or two of them. To create the 6 miles of breakwater required for both American and British sectors, the Allies needed to manufacture 212 caissons of varying sizes. This was not merely a shipbuilding project. It was an architectural program that rivaled the construction of the pyramids, all to be completed in a matter of months. The design challenges were relentless. The English Channel was not a swimming pool. It was a dynamic environment with a tidal drop of over 20 feet. If a caisson was designed for deep water, it would be useless in the shallows. If it was too short, the high tide would submerge it, allowing waves to crash over the top and destroy the delicate unloading operations inside the harbor. Consequently, the engineers had to design a family of phoenixes, graded by size to fit different depths of the French coastline, requiring precise hydrographic intelligence that was dangerous to collect under the nose of the enemy. Furthermore, the structure had to be strong enough to survive the voyage, but cheap enough to produce in mass quantities. Steel was the lifeblood of the war effort, desperately needed for tanks, Liberty ships, and artillery shells. The War Production Board could not spare the thousands of tons of steel required for an all-metal breakwater. Thus, concrete became the material of choice. However, concrete is brittle. The naval architects argued that a concrete box twisting and hogging in the Atlantic swell while under tow would crack and sink long before it reached France. The civil engineers countered with reinforced designs, using steel bars to create a skeleton that could withstand the tension of the ocean. It was a friction-filled marriage of nautical science and civil construction, with the fate of the invasion serving as the officiant. The phoenixes were not the only component of this artificial archipelago. The designers knew that while the concrete walls would stop the waves, they needed a secondary line of defense and a way to bridge the gap between the caissons. They devised the bombardon breakwaters, immense, cruciform-shaped steel structures that would float outside the main harbor. These were designed to break the back of the largest ocean swells before they even hit the concrete wall. They were anchored by heavy chains, floating monstrosities that looked like giant steel crosses bobbing in the sea. Closer to the beach, the plan called for an even more drastic measure to provide immediate shelter while the phoenixes were being aligned. This was the Gooseberry Line. The planners selected dozens of obsolete merchant ships and old warships, vessels that had survived convoys and battles, and stripped them of their sensitive equipment. These ships, termed corn cobs, were to be sailed to Normandy on D-Day, lined up prow to stern, and scuttled with dynamite. Their sunken hulks would form the initial breakwater. It was a sacrificial strategy, sending veteran ships to a watery grave to protect the fragile landing craft. Inside this protective shell of sunken ships and concrete towers, the engineers had to solve the final, critical problem: getting the cargo from the ships to the sand. A traditional harbor used fixed piers, but on the Normandy beaches the tide receded nearly half a mile, turning the harbor into a mudflat twice a day. A fixed pier would be high and dry for hours, halting the flow of supplies. The solution was the Whale floating roadway. The Whale roadways were a marvel of flexibility. They consisted of a series of 80-foot steel bridges linked together by flexible joints that allowed the road to heave and twist with the sea without snapping. These bridges rested on beetle pontoons, concrete or steel floats that rose and fell with the tide. At the seaward end, the roadway connected to massive Spud pier heads. These were essentially floating platforms with 4 giant steel legs. When the pier head arrived, electric winches would drive the legs down into the seabed, anchoring the platform. As the tide rose, the platform would slide up the legs. As the tide fell, it would slide down. This ensured that the docking level remained constant relative to the water, allowing ships to unload at any time of day or night. The complexity of the Mulberry design was terrifying. It required the perfect synchronization of static concrete defenses, sacrificial ships, and dynamic floating steel roadways. Every joint, every valve, and every weld had to hold against the chaotic forces of the North Atlantic. There was no time for a full-scale prototype. The engineers were drawing blueprints for structures that had never existed, based on theories that had never been tested at this magnitude. They were designing a floating city to be assembled under artillery fire, and they had to trust that the math was correct. As the designs were finalized and stamped top secret, the burden shifted from the drawing boards to the construction yards. The blueprints were ready. Now they had to find the hands to build them. The blueprints for the Mulberry Harbors were finalized, but the War Office immediately collided with a harsh reality of the British industrial landscape. There was no room to build them. By late 1943, every established shipyard in the United Kingdom was operating at critical capacity. The dry docks of the Clyde, the Tyne, and the Mersey were clogged with destroyers needing repairs, Liberty ships being fitted out, and landing craft rolling off the assembly lines. The Phoenix caissons were too large to fit into standard slipways, and even if they could, displacing vital warship repairs was strategically unacceptable. The Ministry of Supply faced a crisis. They needed to construct millions of tons of shipping volume without using a single shipyard. The solution was as improvised as it was ingenious. If the dry docks were full, the engineers would simply carve new ones out of the British soil. Along the banks of the River Thames and the solitary estuaries of the south coast, a bizarre excavation began. Drag lines and bulldozers tore into the riverbanks, scooping out massive earthen basins behind temporary levees. These were wet docks dug from the mud, crude and temporary, designed solely to birth the concrete monsters. Once a basin was dug, the floor was lined with rubble to support the weight of the casting, and the construction crews moved in. When a caisson was finished, the engineers would simply breach the earthen levee, letting the river flood the pit and float the structure out. It was a construction method that turned the geography of England into a factory floor. The mobilization of labor was absolute. The project required a workforce of over 50,000 people, but the able-bodied men of Britain were already in uniform or essential industries. So the builders of the Mulberries were a motley army of the remaining demographic. There were graying veterans of the First World War who knew masonry, Irish laborers who had crossed the Irish Sea for high wages, and thousands of tradesmen pulled from the bombed-out cities to pour concrete for the war effort. They worked in a fog of mandated ignorance. Security was paramount. The workers were told only what they needed to know to perform their specific task. A steel bender knew the dimensions of the rebar. A carpenter knew the shape of the shuttering. But no one was told the purpose of the hollow, windowless skyscrapers they were raising from the mud. Rumors spread like wildfire through the labor camps and local pubs. Some whispered that they were building pontoon bridges to cross the Rhine. Others speculated with grim humor that they were constructing floating flats to house refugees after the war. A popular theory held that they were Noah's Arks for a secret weapon test. The reality, that they were building a mobile port to invade France, was so audacious that few guessed it. The pace of construction was relentless. Under the glare of floodlights, shielded to comply with blackout regulations, the work continued 24 hours a day. The appetite of the Phoenixes for raw materials was voracious. The project consumed the nation's supply of steel, reinforcing bars, and cement. At one point, the demand for rock and aggregate to mix into the concrete was so high that gravel pits across the home counties were dredged empty, and trains from the north were commandeered solely to haul stone to the riverbanks. The British construction industry was effectively hijacked by the Mulberry Project. As the weeks passed, the structures began to rise above the levees, dominating the skylines of quiet riverside villages. They were stark, alien shapes, brutalist blocks of gray interrupting the green fields and thatched cottages. To speed up production, the engineers adopted a two-stage process. The base of the caisson, the first 20 feet or so, was poured in the dry basins. Once the concrete set, the levee was breached, and the buoyant base was floated out into the river. It was then towed to a wet berth, a deep-water mooring where cranes mounted on barges would continue to build the walls upward while the structure floated. This created a surreal spectacle on the Thames. Commuters crossing London bridges would look down to see half-finished concrete islands drifting downstream, swarmed by men in flat caps and heavy coats. The river, once the artery of imperial trade, had become an assembly line for a secret weapon. Simultaneously, in the steelworks of the Midlands and the North, the components for the Whale roadways and the Bombardon breakwaters were being forged. This was precision engineering on a massive scale. The telescopic legs of the Spud pier heads required complex gearing and heavy-duty electric motors. The flexible joints of the roadways, which had to twist without breaking, required high-grade steel that was in short supply. Every factory capable of welding or casting was roped into the effort. The various parts were built in isolation to maintain secrecy, labeled with obscure codes, and shipped south to be assembled at military depots. By the spring of 1944, the secret empire of construction had done its work. The riverbanks were scarred with empty pits, and the estuaries were crowded with the finished products. The 146 Phoenix caissons, along with the beetles, whales, and pier heads, were gathered at assembly points, primarily off Selsey Bill and Dungeness. They were sunk in the shallow water to hide them from German reconnaissance aircraft and to prevent them from drifting. From the air, they looked like strange submerged reefs, anomalies in the water that Luftwaffe photo analysts struggled to interpret. The engineers and the workers had achieved the impossible. In less than 9 months, they had consumed 600,000 tons of concrete and 31,000 tons of steel to build a harbor where none existed. But as the structure sat submerged in the English waters, waiting for the signal, a new anxiety took hold of the planners. Building the Mulberries was one thing, moving them was another. These were not ships with rudders and engines. They were rectangular blocks with the hydrodynamic properties of a brick. The invasion fleet was preparing to launch, and the engineers had to figure out how to drag millions of tons of concrete across one of the most unpredictable channels on Earth without losing them to the bottom of the sea. The invasion of Normandy is often remembered as a sudden, violent release of kinetic energy. Paratroopers dropping into the darkness, landing craft charging through the surf, and battleships thundering from the horizon. But for the men of the Mulberry Project, the invasion began not with a sprint, but with an agonizingly slow crawl. While the assault troops stormed the beaches on June 6th, the components of the artificial harbors sat submerged off the English coast, waiting for the signal that the beachheads were secure enough to receive them. That signal came on D-Day +1. The order went out to the holding areas at Selseybill and Dungeness to wake the sleeping giants. The crews boarded the submerged Phoenix caissons, started the massive pumps, and began the arduous process of refloating the concrete mountains. As the water was expelled from the internal chambers, the gray walls rose sluggishly from the sea, shedding cascades of water and seaweed. The greatest towing operation in maritime history was about to begin. The Allied command had scoured the world for tugboats. They stripped the harbors of New York and Boston. They requisitioned vessels from the merchant fleets of Britain, France, and the Netherlands. It was a ragtag armada of over 150 tugs, ranging from powerful ocean-going rescue ships to gritty little harbor workers that had never ventured beyond the breakwater. Their mission was to drag a combined weight of nearly 2 million tons across one of the most treacherous stretches of water on the planet, directly into a war zone. The physics of the operation were brutal. A Phoenix caisson was aerodynamically and hydrodynamically non-existent. It was a brick. When a tugboat applied power, the heavy steel tow cable would snap taut, singing with tension, but the caisson would barely move. It took minutes of full throttle strain just to overcome the inertia. Once moving, the convoy topped out at a walking pace, barely 3 or 4 knots. From the deck of a passing destroyer, the Mulberry convoys appeared to be standing still, suspended in the gray swell of the channel. The journey was a psychological torture for the tug captains. They were defenseless, tethered to massive concrete anchors that made evasive maneuvers impossible. If a German E-boat or U-boat spotted them, they were sitting ducks. If the Luftwaffe appeared overhead, they had nowhere to hide. Their only defense was the overwhelming air superiority established by the Allied fighters and the sheer obscurity of their cargo. To a German pilot, the low-lying concrete blocks might have looked like debris or barges of little consequence, not the secret weapon that would strangle the Reich. While the Phoenix caissons were heavy, the whale roadways were treacherous. Towing the long, flexible steel bridges presented a different set of nightmares. These sections, nearly 500 feet long and mounted on their beetle pontoons, behaved like giant metal sea serpents. In the choppy waters of the channel, they writhed and twisted. If the tug moved too fast, the roadway would buckle or flip. If it moved too slow, the tail would drift in the current and threaten to snap the tow line. The tug crews nicknamed them the Worms, and they fought the tillers constantly to keep the steel snakes in line. The English Channel had become a congested highway. The invasion lanes were packed with thousands of vessels, Liberty ships carrying trucks, hospital ships returning with the wounded, and LSTs ferrying tanks. The Mulberry convoys had to thread the needle through this maritime chaos. Traffic control became a matter of life and death. A collision between a troop transport and a 6,000-ton block of concrete would have been catastrophic. The tugs blew their whistles and signaled frantically to clear the path, bullying their way through the flotilla with the sheer mass of their charges. Inside the Phoenix caissons, the riding crews endured a miserable voyage. These men, a mix of sailors and anti-aircraft gunners assigned to the small platforms on top of the blocks, were trapped on concrete islands with no engines and no steering. They lived in damp, echoing chambers, listening to the sea boom against the walls. They slept on the steel gratings, wondering if a torpedo would shatter the hull and send them to the bottom before they even saw France. The isolation was profound. They were adrift in the middle of the greatest battle in history, yet completely helpless to influence their own fate. As the slow-motion armada plodded south, the weather held, but the sea remained indifferent to their struggle. Cables snapped with the sound of cannon fire, whipping back dangerously across the decks of the tugs. Engines overheated and failed under the constant strain, forcing convoys to drift helplessly until relief vessels could race out to reattach the lines. It was a test of seamanship and endurance that lasted for days. Finally, the hazy coastline of Normandy appeared on the horizon. It was not the peaceful shore depicted in travel posters, but a landscape wreathed in black smoke. The sound of artillery fire drifted over the waves, a dull, constant thumping that grew louder with every hour. The tug captains navigated toward the designated coordinates, Omaha Beach for the Americans and Gold Beach for the British. As they approached the anchorage, the scene that greeted them was one of controlled anarchy. The beaches were littered with the wreckage of D-Day, burning tanks, twisted landing craft, and the debris of war. But amidst the destruction, the survey ships had marked out the foundations for the new harbors. The tugs throttled down, their engines exhausted, and began the delicate maneuvering required to hand over their massive charges. They had done it. They had dragged the components of a port across the sea, but the arrival was only the beginning. The caissons were floating loosely in the swell, and the roadways were drifting in the tide. The engineers now had to perform a synchronized assembly of millions of tons of steel and concrete in the middle of a choppy sea, while German artillery shells from inland batteries still splashed into the water around them. The slowest armada had arrived. Now the construction crews had to build the impossible before the ocean or the enemy could destroy it. The arrival of the tugboats at the Normandy coast marked the end of the voyage, but the beginning of the most dangerous construction job in the history of naval engineering. The waters off Omaha and Gold Beaches were a chaotic no-man's land where the laws of maritime safety had been suspended. The air was thick with the acrid smell of cordite and rotting seaweed. Although the initial landings had succeeded, the German 80mm artillery batteries inland were still active, lobbing shells sporadically toward the anchorage. In this gallery of noise and death, the U.S. Navy Seabees and the British Royal Engineers prepared to assemble the puzzle pieces they had dragged across the sea. The first order of business was to create immediate shelter. The ocean swell was the enemy of precision work, and the engineers needed calm water to assemble the delicate roadways. The Gooseberry Plan went into effect immediately. The captains of the condemned merchant ships and obsolete battleships steered their vessels into a predetermined line, parallel to the shore. These were the corn cobs, rusty veterans of the Atlantic convoys, now destined for one final service. As they reached their positions, the crews set the scuttling charges and scrambled over the rails into waiting small boats. One by one, the ships died. Explosions ripped through their hulls, sending geysers of water into the air. With groans of twisting metal that echoed across the bay, the vessels settled into the sand, leaving their superstructures jutting out of the water like steel tombstones. Almost instantly, the effect was noticeable. The choppiness of the waves behind the line of sunken ships smoothed out. A sliver of artificial calm had been carved out of the restless Atlantic. Into this protected zone came the Phoenix caissons. Maneuvering a 6,000-ton block of concrete into a precise position on the seabed required a delicate touch that belied the sheer mass of the object. Surveyors, working from small launches bobbing in the surf, used triangulation markers on the shore to guide the tugs. They shouted instructions through megaphones, their voices often drowned out by the roar of aircraft engines overhead. The alignment had to be perfect. If the caissons were spaced too far apart, the waves would punch through the gaps and destroy the harbor from the inside. If they were too close, they might crash into each other during the sinking process. Once a Phoenix was positioned, the planting crew scrambled aboard. They spun the heavy wheels of the seacocks, opening the valves to the sea. The water rushed into the hollow chambers with a deafening roar. This was the moment of maximum tension. As the buoyancy vanished, the caisson became unstable. It would list and wobble, threatening to capsize before it hit the bottom. The crews watched the water line rise up the concrete walls, praying the structure would settle flat. With a final ground-shaking thud, the Leviathan would hit the sand. The crews quickly closed the valves, locking the water inside to weigh it down. Then, they moved to the next one. Hour by hour, a solid wall of concrete began to rise from the sea, extending the breakwater created by the sunken ships. Inside the harbor, the assembly of the whale roadways began. This was a task that required the agility of an acrobat and the strength of a weightlifter. The steel bridges were floating on their beetle pontoons, heaving up and down with the residual swell. The engineers had to connect these moving targets to one another, driving massive steel pins through the aligning eyes of the girders. It was a dangerous ballet. Men stood on the wet, slippery pontoons, wrestling with heavy sledgehammers and wrenches. A sudden wave could crush a leg between two grinding steel plates or knock a man into the freezing water between the pontoons, where the crushing weight of the bridge would mean instant death. The Seabees at Omaha and the Royal Engineers at Gold worked with a frantic energy, fueled by adrenaline and benzodrine. They worked in 18-hour shifts, eating cold rations while perched on the steel beams, ignoring the occasional sniper fire that pinged off the metalwork. The centerpiece of the operation was the installation of the Spud pier heads. These floating platforms were towed into position at the end of the roadway. Once aligned, the crews engaged the powerful electric winches. Slowly, the four massive steel legs, the Spuds, began to descend. They pierced the water and drove deep into the ocean floor, anchoring the platform. Then, the winches reversed, and the platform climbed up its own legs, lifting itself out of the water to the perfect unloading height. It was a piece of science fiction come to life, a dock that could walk on water and adjust itself to the tide. By D-Day +7, the impossible was taking shape. Where there had been only open ocean a week before, there were now 2 fully functioning ports. The visual transformation was jarring. A city of steel and concrete had materialized off the desolate French coast. The roadways stretched for nearly a mile from the pier heads to the beach, looking like long, floating highways. The first LST's landing ship, Tank, approached the pier heads. The bow doors swung open and the ramps lowered onto the floating platform. Engines roared to life. Trucks, jeeps, and tanks rolled out of the ships, not into the surf, but onto dry steel. They drove down the floating roadway, the bridge sections groaning and flexing under their weight but holding firm. Drivers who had expected to drown their vehicles in salt water found themselves driving a mile offshore, suspended above the waves, delivering their cargo directly to the waiting quartermasters on the beach. The efficiency was staggering. At full capacity, vehicles were rolling off the ships at a rate of 1 every few minutes. Cranes on the pier heads lifted pallets of ammunition and crates of rations from the holds of Liberty ships, swinging them directly onto waiting trucks. The bottleneck that had threatened to strangle the invasion had been broken. The soldiers on the beach watched in awe. They saw the Mulberries not just as a harbor, but as a symbol of undeniable industrial dominance. The Germans had fortifications, but the Allies had brought their own geography. At Omaha, the American harbor, Mulberry A, bustled with the chaotic energy of the New World. At Arromanches, the British harbor, Mulberry B, operated with a methodical precision. Together, they were pumping life into the invasion force. But the engineers had little time to celebrate their triumph. They were exhausted, their uniforms stiff with salt and grease. They had beaten the clock, they had beaten the logistics, and they had beaten the enemy gunners. However, they had not yet faced the one enemy that recognized no flag and obeyed no treaty. As the last bolts were tightened and the traffic flowed smoothly on June 18th, the barometer in the English Channel began to plummet. The sky turned a bruised purple, and the wind began to moan through the steel lattice of the roadways. The builders of the floating city looked north, toward the open Atlantic, and realized that their greatest test was not the German army, but the ocean itself. Nature has a way of mocking human ambition. For 2 weeks, the Allies had defied the odds, landing an army and building a port where none should exist. They had overcome the German defenses, the logistical nightmares, and the skepticism of their own commanders. But on June 19th, 1944, the English Channel decided to remind the invaders who truly controlled the waters between Britain and France. It began innocuously enough with a freshening wind from the northeast, a direction that every sailor in the channel dreaded. A nor'easter meant that the wind was blowing down the full length of the North Sea and channeling directly into the Bay of the Seine, building up a monstrous fetch of water with nowhere to go but onto the invasion beaches. Meteorologists initially predicted a short squall, but the barometer dropped with terrifying speed. Within hours, the sky turned a bruised, malevolent gray, and the sea began to heave with a violence that had not been seen in the channel during summer for 40 years. The gale that slammed into the Normandy coast was a meteorological anomaly, a winter storm misplaced in June. The wind speeds rose to gale force, whipping the waves into chaotic peaks that crashed over the tops of the Phoenix caissons. The artificial harbors, designed to withstand the typical summer swell, were suddenly subjected to forces far beyond their design specifications. The engineers, who had spent days congratulating themselves on a job well done, watched in horror as their creation was put to the ultimate stress test. The destruction began at the outer perimeter. The floating bombardon breakwaters, the massive, cruciform steel structures anchored miles offshore, were the first to fail. They were designed to dampen the swell, but the violence of the waves caused the heavy steel mooring shackles to snap like cheap jewelry. Once untethered, these 200-foot steel monsters did not sink. Instead, they became unguided battering rams. Driven by the wind and the tide, they drifted relentlessly toward the inner harbor, crashing into the concrete Phoenix caissons and the delicate whale roadways. At Omaha Beach, the tragedy unfolded with agonizing slowness. The American harbor, Mulberry A, had been built on a seabed of shifting sand. As the storm raged, the violent currents scoured the sand away from underneath the concrete caissons. The massive blocks, weighing 6,000 tons, began to tilt and crack as their foundations dissolved. Then, the loose bombardons and hundreds of drifting landing craft smashed into them. The sound was apocalyptic, the screech of tearing metal and the boom of cracking concrete competing with the roar of the wind. The floating roadways, the pride of the engineering effort, were torn apart. The beetle pontoons, tossing wildly in the surf, were smashed by the debris. The steel bridges twisted and snapped, turning the orderly highway into a tangled wreck of scrap metal. The Spud pierheads, the complex floating docks, were battered mercilessly. At one point, the ferocity of the waves was so great that the legs of the platforms were bent and the decks were swamped. The men trapped on the ships and the caissons fought a desperate battle for survival. Tugboats tried to hold the drifting structures in place, but their engines were no match for the ocean. Small landing craft were tossed onto the beach like driftwood, piling up in heaps of twisted steel. The supply operations, the lifeblood of the army, came to a grinding halt. For 3 days, not a single bullet, gallon of fuel, or tin of rations could be landed. The lifeline to the troops fighting in the hedgerows had been severed. The situation was particularly dire because the storm did not relent. It raged for 3 full days and nights, a relentless assault that ground the American harbor into dust. When the wind finally died down on June 22nd, the scene at Omaha Beach was one of utter devastation. Mulberry A was gone. The concrete caissons were broken spines sticking out of the water. The roadways were a twisted mangle of steel washing up in the surf. The American engineers surveyed the wreckage and came to a grim conclusion. The harbor was irreparable. It had to be abandoned. However, a few miles down the coast at Gold Beach, a different story had unfolded. The British harbor, Mulberry Bay, had faced the same storm, but it had survived. Geography and geology had conspired to save it. The seabed at Arromanches was firmer, a rocky shelf that held the caissons in place and prevented the fatal scouring that had doomed Omaha. Furthermore, the British engineers had been slightly more cautious in their construction, doubling up on the anchor placements and reinforcing the breakwaters with extra sunken ships earlier in the week. Mulberry Bay was battered. Certainly. The bombardons had broken loose there as well, causing damage to the outer wall. But the core of the harbor, the Phoenix breakwater and the piers, held firm. The concrete wall stood against the waves, creating a patch of calm water in the midst of the fury. While the American harbor lay in ruins, the British harbor remained a functioning entity, a survivor of the worst the Channel could throw at it. The psychological impact of the storm was profound. The Allied commanders were shaken. They had feared the Luftwaffe and the U-boats, but they had been nearly defeated by the weather. The loss of the American harbor meant that the logistical burden of the entire invasion now shifted heavily onto the surviving port at Arromanches and the ability of the Americans to improvise directly on the open beaches. The Germans, observing the storm from their bunkers, believed that nature had done the Wehrmacht's work for them. They assumed the invasion supply lines were shattered and that the Allied offensive would wither on the vine. It was a reasonable assumption. No army in history could sustain an offensive without a port, and half of the Allied port capacity had just been wiped off the map in 72 hours. But the Germans underestimated the resilience of the engineering corps. The storm had destroyed the hardware, but it had not broken the resolve. As the skies cleared, the salvage crews at Omaha began stripping the usable parts from the wreckage to send to the British sector. The port of Winston, at Arromanches, was about to become the busiest harbor in the world. The storm had tested the concept of the floating city, and while one had fallen, the other stood as a defiant monolith in the gray waters. The focus of the entire logistical war now narrowed down to the surviving concrete walls off the coast of Arromanches. The iron vein had been constricted, but it was still pulsing, and the engineers were about to push it to its absolute limit. As the storm clouds dissipated and the sea returned to its deceptive calm, the strategic map of the invasion had been fundamentally altered. The American harbor at Omaha was a graveyard of twisted steel, but the British harbor at Arromanches, Mulberry Bay, stood defiant. It was battered with caissons shifted and breakwaters breached, but its heart was still beating. The Allied commanders made a swift and pragmatic decision. The wreckage of the American harbor would be cannibalized to save the British one. This decision triggered a somber but efficient salvage operation. American Seabees, swallowing their pride, began to dismantle the surviving components of their destroyed creation. They unhooked the few remaining whale roadways and towed the intact Phoenix caissons from the ruin of Omaha Beach. These parts were dragged down the coast to Arromanches, where they were eagerly accepted by the Royal Engineers. It was a transfusion of industrial blood, a moment of seamless Allied cooperation born of necessity. The reinforced Mulberry B was no longer just a British asset. It became the Port of Winston, the singular lung through which the Allied armies in Normandy breathed. The activity at Arromanches in the weeks following the storm reached a fever pitch. The harbor became the busiest port in the world, a title it held despite having no permanent geography. It was a surreal, floating metropolis. By day, the sky was filled with the swinging jibs of cranes and the smoke of laboring tugs. By night, under the protection of overwhelming air superiority, the harbor was often lit up like a city, defying the blackout regulations that blanketed the rest of Europe. The Allies were so confident in their control of the skies that they dared the Luftwaffe to attack, knowing that the German Air Force was a spent force. Life inside the Port of Winston developed its own unique rhythm and culture. It operated with the complexity of a major municipality. Military police directed traffic on the floating steel roadways, using hand signals to manage the endless columns of trucks. There were speed limits on the bridges to prevent harmonic vibrations from snapping the joints. There were mess halls, repair shops, and even makeshift barracks on the larger concrete caissons. Men lived and worked on these artificial islands for weeks, suspended between the hostility of the ocean and the violence of the front line. The volume of cargo that passed through this bottleneck was staggering. Day after day, the Spud pier heads rose and fell with the tide, accepting the weight of the war effort. Liberty ships docked, unloaded their holds into waiting trucks, and departed, a ceaseless conveyor belt of logistics. The harbor handled everything from 40-ton Sherman tanks to crates of penicillin, from millions of gallons of gasoline to the daily mail bags that kept morale alive. At its peak, the Port of Winston was offloading over 7,000 tons of supplies every single day. For the German High Command, the existence of Arromanches was a baffling strategic defeat. They had spent years fortifying the great ports of Cherbourg, Le Havre, and Brest, believing that the Allies would be forced to shatter their armies against those concrete walls to secure a foothold. They had not anticipated that the enemy would simply bring their own harbor with them. The Germans watched from their observation posts as the stream of supplies flowed uninterrupted onto the beaches, bypassing the Festung Europa strong points entirely. The Mulberries had rendered the German strategy of port denial obsolete. However, the engineers knew that the harbor was living on borrowed time. The structures were designed for summer use, temporary solutions expected to last barely 90 days. But as the capture of major French ports like Cherbourg and Antwerp was delayed by fierce German resistance and sabotage, the Port of Winston had to soldier on into the autumn. The Royal Engineers began a frantic process of winterization. They poured more concrete into the caissons to weigh them down against the heavier winter gales. They reinforced the breakwaters with more rubble and scuttled ships. They were forcing the temporary to become permanent, fighting a holding action against the inevitability of the seasons. The Port of Winston became a symbol of British tenacity. It was an ugly industrial scar on the beautiful French coast, a jumble of gray shapes and rusting iron. But to the soldiers fighting in the bocage, it was beautiful. Every artillery shell they fired, every tin of bully beef they ate, and every replacement tank that arrived to support them had likely crossed those floating bridges. The harbor was the silent partner in every tactical victory, the unglamorous foundation upon which the liberation of Europe was being built. By late July 1944, the Allied armies finally burst out of the hedgerow country in Operation Cobra. American armored divisions raced across France, liberating towns at a breakneck pace, while British and Canadian forces ground down the German armor in the east. This rapid advance, however, created a new crisis: the tyranny of distance. As the tanks moved further from the coast, the supply lines stretched to the breaking point. The Red Ball Express, the famous truck convoy system, was established to rush fuel and ammunition to the front. And the starting point for those convoys, the beating heart of the entire system, was the Mulberry Harbor at Arromanches. The iron vein of the invasion was pumping harder than ever. The harbor was now supporting not just a beachhead, but a mobile war across a continent. The statistics of its contribution were mind-numbing. Over the course of its operational life, the port of Winston landed over 2.5 million men, 500,000 vehicles, and 4 million tons of supplies. These were not just numbers on a ledger. They represented the difference between victory and stalemate. When General Patton's tanks ran dry in Lorraine, it was fuel pumped ashore at Arromanches that got them moving again. When the British artillery devastated the retreating German columns at the Falaise Pocket, it was shells unloaded on the Spud piers that rained down. The harbor's importance only began to wane in the late autumn of 1944. The Allies finally captured the great port of Antwerp and cleared the Scheldt estuary, opening a massive deep-water facility closer to the German border. The reliance on the artificial harbor lessened, and the engineers could finally exhale. The battered caissons, having survived far past their expiration date, were allowed to rest. The dismantling of the Mulberry Harbor was a slow, quiet affair compared to its frantic construction. Some of the floating roadways were unhooked and towed away to bridge rivers in the liberated territories. The steel beetles were salvaged for scrap, but the massive concrete Phoenix caissons were too heavy to move. They were left where they sat, abandoned to the elements. The war moved on, crossing the Rhine and plunging into the heart of Germany, leaving the floating city behind in the silence of the liberated coast. The legacy of the Mulberry Harbors, however, went far beyond the tonnage they delivered. They proved a fundamental truth of modern warfare. Logistics is the arbiter of possibility. The engineers had expanded the realm of the possible. They had taken a coastline that every military textbook declared unsuitable for invasion and turned it into the gateway to a continent. They had proven that industrial might, when coupled with imaginative engineering, could overcome not just the enemy, but geography itself. In the final analysis, the victory in Europe was a mosaic of individual acts of valor. The rifleman at the hedgerow, the pilot in the sky, the sailor on the destroyer. But holding that mosaic together was the gray mortar of the Mulberry Harbor. Without it, the rifleman would have had no bullets, the pilot no fuel, and the invasion no future. The floating city was the great enabler, the silent giant that held the door open while the armies of liberation marched through. As the years passed, the sea reclaimed much of the harbor. The steel rusted away, and the storms of subsequent decades battered the concrete walls. Yet, even today, If one stands on the cliffs above Arromanches at low tide, the shapes are visible. The broken backs of the Phoenix caissons still form a curved reef in the bay, ghostly monoliths rising from the mist. They remain as enduring tombstones to the audacity of the men who built them, a permanent reminder of the time when engineers built a city on the water to save the world. The story of the Mulberry Harbors is not merely a chronicle of concrete and steel. It is a testament to the sheer, unyielding force of human ingenuity in the face of desperation. When the world demanded a miracle, a coalition of draftsmen, laborers, and sailors delivered a mechanical wonder that defied the ocean itself. They did not just build a port, they built the bridge between oppression and liberty. The wreckage that remains off the coast of France today is more than a ruin. It is a monument to the unglamorous, gritty reality of how wars are truly won. It was not a victory of perfect plans, but of rapid adaptation and the refusal to accept impossible as an answer. The Phoenix caissons stand as silent sentinels, guarding the memory of a time when the free world moved mountains and then floated them across the sea. The dominance of the Allied armies was not just a victory of firepower, it was a turning point in the history of engineering. It proved that industrial might, when focused, could turn the tide of history, and that is why these tales must be told.